I wanted to start off by explaining the connection between some of these vocabulary words to better explain how you see this in the real world. Okay, so energy is the ability to change or move an object or a substance. Roller coasters have a lot of energy, which is why it's in motion. When you say that somebody has a lot of energy, that means that that person is in motion. Same thing with energy. Anything that can move or has the ability to change has energy. Now, temperature is the measure of how hot or cold something is. Now, keep in mind when you're thinking and talking about temperature, temperature doesn't stay the same. Temperature can get hotter, temperature can get colder, depending on a lot of different factors. So that in and of itself can change. And that in and of itself, as we've read and as we've explored, temperature is what helps the molecules move, right? It either increases or decreases the movement in those molecules. Now, when you combine the two, when you have something called thermal energy, and we'll get into that a little bit more tomorrow, we start seeing phase change. Where now phase change, as it says in the name, is a change or transition from one state to another. So that in and of itself, we're seeing physically a change in it going from a solid to a liquid or a liquid to a gas. And we're seeing changes in its molecular level too, right? We're seeing that the molecules within each of those substances move differently, especially while they're transitioning from one to the other. So if we're changing and if we're moving and if we're making differences in the amount of movement, that means that all of these are interconnected. Get phase change because there's a change in energy, because there's a change in temperature, because there's a change in pressure. Now let's take a look at yesterday's video that I posted. One cup was full of cold water, the other cup was full of hot water. Now you can see that the hot water had the dye expand much quicker than the cold water. Now, the reason why is because in substances that have a higher temperature, they're going to have more freedom of motion, meaning that the molecules that's inside this hot cup of water are moving at a faster rate than the cold water. And you can see that once you're putting something in it, like this dye. It's a little confusing. Because if I'm saying that the cold cup of water has molecules that are moving a little bit slower than the hot cup of water, then why are they still liquids? Why wasn't there a phase change? Now, the reason why they're still liquid is because I didn't transfer enough energy in or out for them to phase change. I did change the temperature, meaning that I was inputting or transferring in energy in the hot cup of water, but it wasn't enough for it to fully evaporate. And I did transfer energy out, meaning that I decreased the temperature of the water in the cold cup, but it wasn't enough for it to fully freeze. It has to hit the right amount of energy being put in or out for it to phase change. Just because you're inputting a little bit of energy or taking out a little bit of energy doesn't necessarily mean that there's going to be a phase change every single time there's a change in temperature or a change in energy. Example 2. We've seen this simulation several times where we have, in this case, we have a solid, right? And it's staying a solid at 36 degrees Celsius, which is actually pretty warm. Now, if I were to do anything to this, meaning if I were to transfer energy in, okay, if I were to transfer energy into this substance, I'll see slowly a change in the movement of these molecules, right? They're not as stiff, they're not as bunched up as they were before. And the way that energy was being transferred in was through temperature, or in some cases pressure, but in this case we're adding energy or taking out energy through temperature. Same thing if I were to transfer energy out. Okay, if I were to decrease the energy, okay, I would decrease the movement in the molecules, right? They're starting to go back to this very rigid formation, this very rigid structure, and the temperature is dropping. Okay, the more I decrease the temperature, the less movement I'm going to see. The more energy I put in, the more movement I'm going to see from those same molecules. And the higher the temperature is going to be.